Hello everyone, my name is Rishabh Bafna and in this video we are going to solve a GATE CS 2022 question on C programming. So this question is regarding pointers concept. So you can see this, we are using pointers. Also we are using 1D arrays. So this question is regarding 1D arrays and pointers. So and we need to find what is going to get printed. So before getting ahead, let's see some basics of pointers and then we'll proceed to this question. So what is a pointer? So pointer is a variable which is generally used to store the address. So consider this example. A is an integer containing 5 and then PTR is a pointer which is pointing to A. How it will point to A? It will store the address of A. So let's say the address of A is 1000. So it will store 1000. Also PTR will have some address. Let's say it is 2000. So you got the point. So pointer is a variable which is generally used to store the address. So PTR is a pointer variable which is containing 1000. 1000 is the address of this integer. So we'll be using two notations, star and. So let's see about this. So pointer variable is declared using star. Now, since it is declared using star, star is this star operator is used as pointer to a variable. And why we use this AND operator? So this ampersand operator is used to get the address of the variable. So now you got to know about the notations used in pointers. In this question, we have used star, okay, star as well as and. So these concepts will be useful. Now, so star is also called as dereference operator. So there are different naming conventions for star. So let's also write it. So star is called as indirection operator. Star is also called as dereference operator. Star is also called as value at the location or address. And star is also called as value. So object at the location. Or address. Fine. And so let's see about and then we'll see this example. So and is called as address of variable or operator. Fine. Now let's see an example through which we'll understand the pointers concept completely. So we are taking a as an integer. So a is an integer containing value 10. So see this, I'll draw it. Okay, a is containing 10. Now int star ptr. So star ptr. So ptr is a pointer variable of type integer which stores the address of an integer. So int star ptr equal to and a, address of a. So we are going to store address of a in this ptr, in this pointer. How will we do it? Let's see. So first of all, we need to find what is and a. I have printed address of a. See, I have printed it here. So value of a 10, address of a. So this is the address of a. Let's just write it. Address of a is 0x7. So I'm writing this one. Okay, I'm writing this one. 0 x. So this is hexadecimal. 7 FFED7. Sorry for the EFEDF4897C. So this is address of A. Now in the PTR we are going to store this. So if you refer this one, so 0x7FFED F4897C. That's it. So if you store this, we are trying to point to this PTR is trying to point to this A. Easy, because we stored its address in PTR. Now PTR will also have some address. So let's see the address. So value of PTR. So value of PTR will be this address. Address of PTR and PTR. So see, this is the address of PTR. Just I'll mention it. 0x7FFED. So I'm writing this one. Okay, ED7F48980. Fine. So this is the address of PTR. Now if you see this, okay, size of, let's see this print statement. Size of A. What is size of A? So A is an integer. So it would be 2 bytes or 4 bytes, or it would be anything which is set by the compiler. So it is compiler dependent size. Right now it's 4 bytes. So this is a 4 bytes. Now size of address of A. What is size of address of A? Address is of 8 bytes. And then size of PTR. So what is PTR storing? This PTR is containing address itself. So address is of 8 bytes. So 8 bytes. Size of PTR is 8 bytes. Now size of address of PTR. This address. So whenever we say address, we got to know that it should be 8 bytes. So it is of 8 bytes. So in this scenario, integer is taking 4 byte and address is taking 8 bytes. So then that's it. So this is pointers concept. And now, so to get the address of any variable, so we'll use ampersand. See this second statement, and a, address of a 0. So this one. And PTR, address of PTR, this one. See this is address of PTR. Now for a pointer variable, star PTR will give this 10. So if you observe this, star PTR, see, value of integer pointed by PTR 10. So we are trying to dereference it. So that is why it is also called as the dereference operator, or value at the location. Value at the location. So this particular location is 10. Now Now let's see one more thing. When we write this int star ptr, what is that we actually get to know? Ptr is a pointer to an integer storing the address of that particular integer. I think I should write it. It would be better. So int star ptr. So what does this indicate? Ptr is a pointer variable. Ptr is a pointer variable of type integer where we can store so address of that particular integer. Ptr is a pointer variable of type integer where we can store the address of the integer. Right. So this is the meaning of this statement. Fine. So in order to solve problems, we'll not use this big addresses. Just for the sake of simplicity, we'll use addresses like 100, 200, 300 and so on, or maybe 1000, 2000 and so on. So just for the sake of simplicity. Now let's see the same thing with okay, simplified convention. So int a equal to 10, int star ptr equal to and a. The same thing which we did earlier. Okay, this int star ptr equal to and a, I just split it into two statements. Fine. Now how can we represent it actually? So we can represent it this way. Just have a look at it. Representation. So a is containing 10 and let's say the address of a is 100. So for the sake of simplicity, I told you will use 100, 200, 300 and so on, or 1000, 2000, 3000 and so on. Now int star ptr. So ptr is a pointer variable and we are trying to store the address of a in this ptr. So we'll store 100. Fine. So if we store 100, what will happen? We will point here to that particular integer. So let's say the address of ptr is 200. Simple. We'll use this kind of naming convention for addresses from here onwards. So we'll not use this exact. And let's solve this. Also, there's a concept of 1D array involved. We'll also deal with it. Let's see one more thing. So in this problem, so a is an integer which is containing 10. Okay, a is containing 10, b is containing r character, and float f is containing, so f is containing 3.14. Now int star ptr equal to and a. So we are using a pointer variable which is pointing to this integer. How? By storing the address of that particular integer. I told you we'll be using this kind of addresses: 100, 200, 300. Let's say this one address is 400 and we are storing 100 here. So simple. So this is the entire scenario right now. Now let's see what all is getting printed. It's a value of a, so percentage d a. So these are format specifiers. So for integer, we use %d, character, %c, float, %f. So 10 are 3.14. Now I have to show you one point, important point. So a PTR variable, if it is pointing to an integer, it will dereference the size of that particular integer. So if integer, so let's say size of A. What is size of A? A is an integer. Size of A is 4 bytes. And if you observe size of star PTR, it will be 4 bytes. So pointer will dereference 4 bytes because it is pointing to an integer, and integer is containing 4 bytes. So simple. So if integer is of 4 bytes, then integer pointer can dereference 4 bytes of data. In case if integer is of 2 bytes, then this integer pointer can dereference 2 bytes of data. Simple. And so we can say, so from these points, what can we conclude? We can conclude that the pointer variable can dereference or access number of bytes depending on its data type. Fine. Let's deal with one more thing, 1D arrays, and then so z of 1 and z of 1, z of 0, z of 1. So we deal with this this particular 1D array, and then we'll solve this question. So let's see. So z is a 1D array containing 2 integers. First one is 10 and the next one is 11. So this is at 0 index and this is at index 1. So z of 0 will be what? It will be 10. Obviously, value present at 0 index. Z of 1 will be what? It will be 11. But so you must be knowing about this, but let's see some interesting fact. Z of 0 is internally implemented as Z plus 0 star. So this is how we implement it. Let's see, let's just use some conventions. Star Z plus 0. Now, what is Z? In a 1D array, Z indicates the base address of 0th element. So what is the address of 0th element? Let's say it is 100. And let's say this one, if we consider integer as 4 bytes, let's consider it as 2 bytes right now, 102. You can consider it as 4 bytes. For the sake of simplicity, I am using 2 bytes. So no worries. Fine. Z in a 1D array will indicate base address of 0th element of that particular 1D array. So I'll state it. Base address of 0th element of the 1D array. Now, what will this Z plus 0 indicate? So Z plus 0. So we are trying to add 0. It means we are not trying to add anything. So it will remain same base address of 0th element of the 1D array. So instead of taking 0 example, let's see one example. So maybe it will differentiate this statement. Looks nice. So if we add 1 to it, what will happen? It won't be 101. So 100 plus 1 won't be 101, because right now 100 is the base address of 0th element of the 1D array. Now, if we do plus 1, we will get the base address of first element of the 1D array. So plus 1 will give 102. So not, it won't be 101. Fine. Now let's put a star here. What will happen if you put a star? It will dereference it. So after dereferencing, what will we get? Right now we are having 102, which is base address of first element of the 1D array. If we go one level inside, put a star, we'll get 11. Value of first element of the 1D array. Fine. We'll get the value now. So simple. So if you observe this, we are trying to use z of 0 and z of 1 in this question. So I'll share an interesting fact. Z of 0 will be implemented as z plus 0 star, which can also be interpreted as 0 plus z star, which can also be interpreted as 0 of z. So this may seem surprising, but yeah, you can code it and see it will work out. Fine. So this is first point, and the second point, z of 1 equal to z plus 1 and then star. So star z plus 1 equal to, so z plus 1 and 1 plus z same only. So you can rewrite it as star 1 plus z. And then, so we can also write it as 1 of z. So this notation may seem overwhelming, but yeah, it's easy. So 0 plus z whole star, or same thing, z plus 0 whole star, that is z of 0. So let's now start with this problem. So it will be easy now. Fine. Hash includes stdio.h, will include standard input output functions like printf, scanf, implementation of printf, scanf in our code, so that we can run this function easily. Now int main, the code will start from main. These are for command line arguments. So let's see the code. This is main code. So int x equal to 1. So x is an integer variable containing value 1. Fine. What is the address of x? Let's say the address of x is 100. Fine. Now int z to 10, 11. So z is a 1D array containing two integers 10 and 11. Let's draw it. Z is 1D array containing two integers. First of all, first integer is 10, second one is 11. Now the address of this, consider it as, maybe you can consider it as 200. So because we took 100 here, 200. If integer is of 2 bytes, so 101, 201, 202. So this address will be 202. Fine. So basically this is assumption. You can take any assumption. Integer is of 2 bytes or 4 bytes. Right now we are taking 2 bytes assumption. But if you see in this code, so size of A is an integer which is of 4 bytes. Integer size is of 4 bytes in this code, and address size is of 8 bytes. So all these are addresses. So address size is of 8 bytes and integer size is of 4 bytes in that particular code. but then we are using 2 bytes for integer right now. So int star p equal to null. So what is this star p? So p is a pointer variable. Because we use star, we should get the hint that p is a pointer variable. So p is a pointer variable of type integer, isn't it? And which is used to store the address of any integer. Right now, p is containing null. Now let's say the address of p is 300. For the sake of convenience, 100, 200, 300. Fine. Now p equal to and x. We are trying to store the address of this x. Address of x, that is 100 in p. So we'll cut this. Okay, we'll cut this and store 100. What will happen if we do it? It will point to this particular integer. That's it. Simple. Now let's deal with next statement. Star p equal to 10. Star p equal to 10. We are trying to dereference this p, pointer p. So what is located at 100 location, contents of or the value of location pointed by the p pointer, that is changed to 10. Simple. Now let's see this one. P equal to and z of 1. So initially we'll find out z of 1. Well, what is that? So this one is 0th index and this one is first index. Z of 1, I told you it is 11. 11 address, what is it? 202. So and z of 1, address of this z of 1 is what? 202. We are trying to store 202 in p. Now let's see. We'll cut this and write 202. If you do it this way, what will happen? We are pointing here, and then this won't be valid. This link won't be valid now. Now star and of z0 plus 1 plus equal to 3. Let's see what is this one, and then we are trying to just increment it by 3. So and z of 0 plus 1. What is and z of 0? Z of 0, you know, z of 0 equal to 10. What is present at 0 index? 10. And z of 0, address of z of 0, address of this is 200. Now and z of 0 plus 1. So if you do plus 1, you will get 202, not 201, because right now we are pointing to the address of 0th element of the 1D array Z. So later, if we do plus 1, we'll point to the address of first element of 1D array Z. So that is 202. Plus 1 will give 202. So 202. Fine. So star 202. So it is effectively like this. Star 202 plus equal to 3. We are just trying to increment this value. Star 202 is what? This 11. So we are just trying to increment this 11 by 3. 11, 12, 13, 14. Simple. Fine. Now what is getting printed? Percentage D. Percentage D is a format specifier for integer. Initially we are trying to print X. So X, and then this one is for Z of 0, and this percentage D is for Z of 1. So X, what is X? X is containing 10. So 10 will be printed. So output 10. Then what? Next one, Z of 0. So Z of 0 is also 10 right now. So 10. Now the next one, Z of 1. Z of 1 is 14. It's fine. Output is 10, 10, 14. Simple. So let's see. Option E is the correct option. So 10, 10, 14. So this is the answer. Hope you got this concept of pointers and 1D arrays. So I have explained this previous year GATE CS question along with the concept. Not just this explanation, I have explained it with these concepts. I hope you like this explanation. Thanks a lot.